Hi, welcome back to this sixth video in a series. I'm learning how to use Python and other technologies to build a useful web app. Currently, I'm still working on learning basic Python, and I'm also using the Git version control system now to help me track changes in my code, and also to prepare for the future when I expect to be collaborating with other users on the same project. Currently, our program consists of two files. The mapperdata.py file has some hard-coded information in it that describes the data structure that we want to use, and the usermapper.py file takes that data structure and prints it out as a XML file, and the usermapping.xml file is the output we get. I have an example XML file here which shows what we want. Let's have a look at mapperdata.py. Here we can see the hard-coded information. It's all Python dictionaries. We have parameters that are set up for the devices. I have device names and student names with student information and also specific information about each device. And the usermapper.py file contains the code that prints out the XML file. So it just goes through the data structure that's generated by the mapperdata.py file. I just have the actual tags hard-coded as strings in this file, and it just goes through a few nested loops and builds the XML file, which should look something like this. You can see there's a lot of improvements that I can make here. I want to make the program more flexible. I want to be able to change the inputs in a more user-friendly way using a configuration file. At this point, I've already got a version of the program. So I'm going to use the Git version control system to mark this as a release. So to do this, I go into the directory that my project is in, which is the usermapper directory, and I will tag this release. I'll go git tag 0.1. This allows me to come back to this release in my version history at some point in the future, if I need to. As I discussed in my previous video, whenever I want to start some code, I probably should create a new branch. This lets me do all of my new work in a separate branch without making any changes to the main branch. And this way, if I ever want to go back to where I started from, I can do that much more easily. To create a branch, use the git command, git branch. If you type it all by itself, it shows you what branches you currently have. Right now, I have just one branch, the main branch. Now I'm going to create a new branch. Give it a branch name. There, this is the add config file branch. We can see that we have two branches now. One of them is named add config file. So I will switch to that branch. To do that, you check out the branch. Kind of like checking out a library book. And it auto-completes the branch name if you want to do that. In that branch, all the changes I make to this directory are going to be tracked in this branch. I always like to run a git status command before I start any work. I just want to make sure that there's nothing already there that needs to be taken care of. Now I need to do some planning. Network engineers will be familiar with configuration files. We work with them a lot. They're in different formats. Some are in XML format, which is similar to the output file that our program is going to create here, but I find that to be a little bit too wordy. I like the YAML format. I know a lot of network engineers don't, but I like it for small, simple configuration files. Not for really long and complex configuration files, but definitely for small, simple configuration files that are quick and easy to write. Let's do a little bit of research on YAML and Python. I found that the best place to look for information about YAML is the YAML Wikipedia page. There doesn't seem to be a lot of great documentation for it. Even the official YAML site didn't really have much that looked good to me. As I searched the internet for how Python works with YAML, I discovered that it's not part of the standard Python library. So I'm going to need to install a package into Python that contains some code and some modules that help me read and write YAML files. This way I don't have to do all that coding myself. One of the reasons I was attracted to using Python is that it comes, number one, with a very large standard library. So there's a lot of functions I can already use in Python, and there's a very large community of people writing packages and other modules that I can just reuse in my Python code. So in this case, there's already a module called PyYAML, which I believe is recommended by the official YAML webpage. Let's go down here and see what it says about Python. There's a number of packages that support YAML in Python, and the first one is PyYAML. This project, if it's an official package, should also be in the Python package index at pypy.org. That looks good. It's on GitHub. It's got many stars. Let's have a look at it. Fairly active, so I think this is a credible project and it's okay to add it to our project. Before we install this package on our system, we need to learn about Python virtual environments. Python virtual environments are an optional feature. From what I've read about them, they help you keep your host system's version of Python clean. Packages that you need to install to work on different projects should be installed in virtual environments so they don't impact your host system, and also so they don't impact other projects you're working on. Python makes it easy to create virtual environments. It comes with its own little script that creates them for you. So if you are in your working directory where your project files are located, you can create a virtual environment in that directory with the command python -m venv for virtual environment, and then give that virtual environment a name. It seems that the general convention is people always just call it env. And this env virtual environment only exists in this folder. If I have another project in another folder, I can also call that virtual environment env. There's no magic here. All this script did was copy the system version of Python, copy all of those Python interpreter files into a new subdirectory in my project directory called env. It also copied in some helper scripts like activate, which in the next step we'll use to start the virtual environment. We've added a whole new directory full of files to our project, and Git is now tracking this. But we don't want Git to track that folder, so we need to add it to our git ignore file. After we save it to the git ignore file, it should disappear from our Git tracker. There, it's gone. And the only thing that Git is tracking now is the fact that the git ignore file was changed. The way that you take a branch that you've created locally and push it up to the remote repository is to use the git push with the -u tag, which stands for set upstream. And as always, origin is the code name for our remote repository. Now we have a branch on our remote repository at GitHub. As a matter of fact, let's go quickly have a look at that. I see I have two branches, and one of them is called add config file. And if I click on that branch, I can see all the files that are part of that branch. Let's see what the git log looks like on this branch. There you can see we're sort of telling the story of our repository right now. We don't have a lot done, but you can see how this will add up over time and why it's important to keep coming back and making sure that we're using Git properly. I'm getting tired of entering in my user ID and password all the time. So before we get into Python coding, I'm going to do one last diversion and create a personal access token so that I can just run Git commands without entering in my user ID and password. To get your personal access token, you have to go to the GitHub website, and it should be under Settings. I don't see anything here that looks like what I'm looking for. Actually, it's under my profile settings, which for some reason are different from settings. These settings are all about me. So there's two settings in GitHub, it looks like. One is for the repository and one is for my personal information. And personal access tokens are under developer settings. Then I click on personal access tokens and generate a personal access token. I should put in a note about what it's for. And it's important whenever you're creating any kind of a access key to only give it exactly the permissions it needs and no more. And so really I only need to access the repository. I don't need to do any of these other functions that GitHub supports. So that's all I will enable. Then I will generate the token. And I need to copy it. You can click on this little symbol to copy it. And once I navigate away from this web page, I will never see that token again. So I need to make sure I put it somewhere. Now, in order to make this work for my remote repository, I have to change the URL that identifies the Git remote. There you can see what the URL is, and that needs to change to a URL that now includes my user ID and the user access token. And then I paste in my access token. Let's see if this works. If I do a git fetch, it doesn't ask me for any tokens, but maybe I need to do a git push just to be sure. It's not asking me for my user ID and password anymore, so I have a little extra convenience while I'm using Git. You can manage these tokens by deleting them and creating new ones as you need to. For example, in my case, I'm going to delete this token and create another one that doesn't show up in this video. Now let's get to work in this branch that we have created. Remember, we have a branch created called add config file. We can see that here in GitHub. And we also have a local branch, also called add config file, and you can see that I'm currently using that branch. That branch is currently checked out. So all of the changes that I make are going to occur in this branch. And should I ever need to switch back to the master branch temporarily, those changes will not be in the master branch. It's time to start programming again. I need to make some design decisions. And I think a lot of the program design is going to be driven by the config file format. I want the config file format to be simple, clear, and flexible, but this script is a little bit opinionated in that there's no point in creating a config file that looks almost like the usermapping.xml file. I want to create classes of users and then just say how many users, and they'll all have similar configurations. And the same thing with devices, a class of devices, and they'll all have similar configurations, and every user gets access to all the same devices. That simplifies things, and I don't have to try to specify which device is for which user, because again, if I do that, I may as well just write out the usermapping.xml file all by itself. I'll start with a configuration file named config.yaml. YAML files usually represent key value pairs or lists of values. A user's key, and under that will be a list of users. and a devices key. And under that will be a list of devices. Under the users key, whitespace is significant in YAML, which is one of the things some people don't like about it, but then whitespace is significant in Python. So I might have 2 types of users or more. This is flexible, so you can just, for example, you could say I need trainers and students. And who knows, maybe someday you'll say, and supervisors, right? It's flexible. You can just add what you need, and the script will know to create more of those in the XML file when it writes them out. And devices, what classes of devices will we have? Right now we have servers and routers, but maybe someday I'll add switches, maybe radios, things like that. And I'll just keep it simple for now, servers and routers. And then each student is going to have some attributes, some key value pairs. So I'm thinking ahead to how this will look in Python, right? I'm thinking that each one of these key value pairs is really an element in a dictionary. So users and then its value is a dictionary that contains key value pairs which name the user classes. So trainers is the key to another dictionary that contains key value pairs, which is the student or the user attributes for the trainer. What do they need? We need to know how many there are. Say there's 2 trainers in a class. I need to give these people a name that's going to show up in the usermapping.xml file. And it's not necessarily going to be related to the class. Like I could call them trainers, but maybe I want to have a different name for the actual students. But they're all going to be similar names because this is going to automatically generate potentially dozens of students in a class, for example. So there'll be a prefix and a suffix. The suffix will be a number that increments, and the prefix will be whatever we want it to be. And of course, we need a password. And I was thinking about this. We could specify a password, but then every trainer would have the same password. Or we could have a word like random. Actually, I don't know if I need to. I wonder, maybe these will automatically be strings. I know the 01 I need to put quotes around to make sure it's interpreted as a string. I think that's good enough for each user, right? So then for the students, I'll do the same thing. I'll just make it easy by cutting and pasting. And let's say, in this class we could have 10 students, and each student will start with the user prefix student, student 01, student 02, etc. And the password is random. Same thing for devices. Now, devices can get pretty complicated when I think about everything we need to say about a device. So let's think about servers. We need to know how many servers. Let's say there's 4 servers in our lab, and they need a name. And we'll do this the same way we did the student names. The name suffix doesn't have to always start at 01. It could start at some other value. For example, here I'm looking ahead to say that there'll be 12 devices in this lab, 8 routers and 4 PCs. The routers will be number 1 to 8. And just to make it easy to remember addresses, servers will be numbers 9 through 12. Then every device, when you add them all up, is devices 1 through 12. And the same thing for host name. Every device needs its own host name, which might be different from the name, especially if you're just making it an IP address, for example. So it needs a host name prefix. And since I'm using an IP address, I have to make that a string, so it's interpreted as a string because I'm typing in numbers. I already know what IP addresses I normally assign here, which is why I've started it with 109 for my lab. And then a parameters dictionary. So this parameters key points to a dictionary of key value pairs that lists all of the items that we need in here. We need a host name, a port, a username, and a password for each device, and a protocol. Since it's a server, it has a graphical user interface. The host name is where the IP address will go, and it's currently blank because that has to be generated for each individual server, and that has to happen after this configuration file is used to build the data structure that's going to represent the entire lab. And that little tilde in YAML just means a null value. And we'll just copy this for the routers. And the routers, let's say they all start with the prefix R and they start with number 1. We access them with SSH. And that's it. That is our configuration file. I'll put some spaces in here just to make it easier to read. Now I'll save the config.yaml file. And at this point, I should see what Git is tracking. I see it notices I've created a new file named config.yaml. Configuration management isn't just about saving code changes. It's about creating a story of how the code evolves over time. Every commit should be focused on something specific. So I'm not going to do anything more until I commit this change. I'll add this to the staging area and commit it with a descriptive message. Now I can continue on with my development. Let's have a look at the file we're going to modify. The mapperdata.py file currently contains something similar to this YAML file. It's got some structured data, which by the end of the file we turn into a data structure that we can use to describe the usermapping.xml file when we process it using the usermapping.py program. I'm going to end up deleting most of the code in this file, pretty much all of the code in this file, and then looking over here and trying to figure out how I can create the exact same data structure that this file creates today, except use the configuration file as the basis for that. The basic information, for example, device parameters, currently that's in a dictionary stored in the mapperdata.py file, and now it is stored in the configuration file in a slightly different structure, and I'll need to adapt that. But in the end, the interface to the usermapping.py file is a specific data structure, and I need to recreate that from the configuration file. That's what I'll do the next time I get started on this. I think I've gone far enough tonight, and I don't have any more time. So I'll stop here, and I'll think about exactly how I'm going to accomplish this. I'll have to create some code that reads in this file here, and this is where I'll use the PyYAML package that I'm going to install into the virtual environment that we created at the start of this video. Thank you very much for listening. Have a great day.